Just to let you know that the tutorials questions, you can just see the answers. So it's straightforward for the answers. But however, question 11, I have to go through the movement. The first thing you need to know in order to understand this question is to first understand the table that is being brought forward earlier in here. Where is it? Here. Okay, you need to understand the XOR gates 000. Okay, these are the things that you need to understand first. With this understanding, then you can do this question. So doing this question, you also need to know the first step you need to understand is actually this one. The V reference is equals to 8 volt and the R is equals to 100 ohm. So individual R, you have to know how many R's are there. You have to understand. Okay, if it's 2R, 4R, 6R, then you have a different type of voltages and such. So you have to really understand how to calculate. And then, so the voltage over each of the 100 ohm reference voltage. So each of them has a referencing voltage of 100 ohm. Okay, so each of them has a voltage of 100 ohm. And then their voltage value is actually 8 volts. Okay. So 8 volt divided by 8 resistors, okay, they will each have a 1 volt. So each resistor contains 1 volt in this case. Okay. Why is because they are connected in series. Okay, actually I may not have didn't tell you that, but yeah, this is actually the flash ADC. Okay, flash ADC. So this flash ADC is connected in series. These references are connecting in series. As you can see, they are all one straight line, and then they may be tapped into the comparator for each series of comparators, I would say. So these are all series. So this is why if you divide it by resistors, each of the resistors across, they have a different type of voltage. So across one resistors, at this point you have a 7 volt. At this point you have a 6 volt. At this point you have a 5 volt. And then at this point you have a 4 volt. At this point you have a 3 volt. At this point you have a 2 volt. At this point you have a 1 volt. Nonetheless you have 0 volts over here. Right? So this is the thing that is kinda plotting out. So you have to already understand how the things goes. Okay? And then they may actually ask you to find what is the current across this thing. So from here you can actually know that the current is actually the same. No, not the same. If they them. So if they ask you to find the current, right? The current is not the same in series, they have to add up, right? So 8 volts in this case, you know that V equals to IR. So you know that your volt in this case is 8 volt. And then each resistor is 100 ohm, right? So in order to reach, okay, so there will be no resistors, I think. Yeah, my fault. Okay, so for the voltage wise, they should be add up. Okay, voltage wise they should be added up. I actually say the correct thing lah. Okay, the voltage they are added up in order to have what am I talking? The voltage is the potential difference between 8 and 7. Okay, so there will be 1 volt. There will be 1 volt difference. So if you add them up together, you have total of 8 volt from the power source. Okay, so in this case, the voltage in a series, they actually add up together. So this is why we say that this equals to 1 volt, right? 8 volt divided by 8, because they are series, so they have 1 volt each. But in a more detailed way, the current is the same throughout the whole series circuit, if you remember. Okay, the current is the same throughout the whole series circuit. So one way is to actually to find the overall resistance for the whole series one. So the overall series circuit is actually 800 ohm, because individual resistors is equals to 100 ohm. So you add up to 800 ohm. So in this case, you have 800 ohms already. You have a total voltage of 8 volts. So in this case, if you were to divide, you will have a 0.01 ampere. So if you were to multiply 0.01 ampere with one of the resistance is R times 100 ohm, you will have 1 volt. So this is how it's being derived. So if the different R is like 200 ohm and then the different voltage is maybe different type of voltage, then you will have a different type of voltages across this series. Alright, you have a different type. Maybe it's not, if your V reference is like 20 volts, in this case this will not be 7 volt, this will be some other voltages already. So you need to know how to calculate this one first in order to proceed on to the next analysis, so to speak. Okay, so what do we do next? So the first step is actually to define all these things already, right? So the second step is actually to compare and then to reduce the binary code. So let's say if you were to do 4.5 volts, okay, so let's say I take in a V in now, a V in of 4.5, so it comes in, and then at this point it stops, and then it goes here, and then it compares with your V reference. Then okay, dude, I'm lousy because 4.5 is lesser than 7 volt, so definitely this is, at this point is 0, right? Output is 0. You know what I mean? I think you know what I mean, because yeah, you're comparing 7 volt to 4.5 volt. If the 4.5 volt is, if this V in is lesser than the V reference, then it will be 0. So it is 0. So same thing for here. This is all 0. Okay, up till here, this is 0 also. Okay, hold on. Let's try first, okay. So at this 5 volt like stage, this is also 0. Okay, because 4.5 is lesser than 5 volts. Up till here at 4 volts, okay, 4.5 is larger than 4, right? So definitely you have a output of 1 over here, right? And then this is actually 1. And then if you were to continue on, 4.5 is larger than 3 volts, right? So this will be 1, this will be 1. Similarly, 3 volt is larger than 2 volts, so you have like, 1, and so on and so forth. So from here you can see you have a voltage of at this point it's 1, 0, 1. Okay, you can have an output of this one. So you have a 1, 0, 0. Sorry, I think I ran wrong place. I think at this node it goes out, so it'll be 1, 0, 0. So if I'm not wrong, this is actually 1, 0, 0. Okay, so it's the same thing downwards. Okay, so I hope I give you the good concepts of this thing. Nonetheless, I can do another one. Okay, maybe I do another input voltage of maybe 2 volts. If it's 2 volts, I'll not go through all this. You know that this all will be zeros, right? Up till here, at this 2 volt, it is the same as the referencing voltage, 2 volts, right? So this one will output as 1. This will output as 1. And then this is 0. This is 0 also. If you were to remember, because 2 volt, because this is the red color one is the referencing voltage, right? So your input voltage is 2 volt, which is lesser than your referencing voltage. So this is why it's 0 over here, 0 over here. And up till here, 2 volt is the input voltage is now the same as the referencing voltage. So you have a 1 over here. So therefore you have a 1, and then you have this portion over here. It goes in. You have a 1 over here binary. So my fault. Okay, this shouldn't be at this point 2, and if it's 2 volt, it cannot be the same. Okay, the So in other words, right, another thing you need to take note is that V reference has to be smaller than the V in order to give out a 1 binary. Okay, why? It's because if you know the comparator rule, right, this is actually V1 minus V2. In this case, V plus minus V minus. If 2 volts minus 2 volts, you actually have 0. So you're actually outputting a 0. In this case, no lah, right? So therefore, you have to be very careful. So in this case, up till here, okay, this is 2 volts. This is your V in line. So until here, it is actually 2 volts. 2 volts. If you can do it out, you cancel it out, you have actually 0, because you have no voltages at all now. Still 0. Up till here, if you were to compare 2 volt and 1 volt, the difference is a 1 volt. So you can actually have a 1 over here, and then there will be a output of this one, and then you have output of 1, which is 0, 0, 1. Okay, and then yeah, so I hope that you understand this part. Maybe we should do a 8 volt also, in order to ensure everything is synced into your brain. Okay, so eventually we have a 8 volt over here. So 8 volt in this case is actually here, referencing to this one. 8 volt is larger than the 7 volt, right? So there will be a output of 1 over here, right? There will be output of 1, and then there will be a output of 1, and then the rest is also 1, 1, 1. So end up, these are all zeros, 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 and only this is the 1 over here. So this one will go to here, while this also will go to here, and also, as you can see, that they are all going into these things. And if you were to go down, you all reach up to here. Okay, if you were to follow the line, okay, if you were to follow the line down, there will be 1, 1, 1. So this is the highest volt, 1, 1, 1. But however, there's a mistakes in the tutorial sheet. It says 1, 1, 0. Okay, which is not the case lah. It's 8 volt, because 8 volt is the highest bit already, if you remember. 2 to the power of 3. In this case, there is only 3 digits, meaning 2 to the power of 3, 2 to the power of 2, and 2 to the power of 1. So in this case, this is the highest bit that it's talking about already. Default. It's 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. Because if you add up, this one is 4. This is 2, right? 2 to the power of 2 is 4, 2 to the power of 1 is 2, and 2 to the power of 0 is 1. So if you add up together, you have... Never mind, they didn't correspond well to the 8 volt. I thought 8 volt, if you were to put it in, it should reflect 8 volt, but I think it is just some binary numbers, that's all. It didn't correspond to the 8 volts, I thought. So yeah, sorry to confuse you, but yeah. So that's let you know that it should be 1, 1, 1 in this case. Okay, and then what do I need to do? Now if you know that this is, let's say if you remember the 4.5 volt, right? You have the output is 100 in 2, meaning, okay, maybe I should go down a little so that I have more spaces. So I have 100 base 2. So if you want to convert into base 10, what are you gonna do? What are you gonna do? What can you do? Okay, you know that this is actually 2 to the power of 0, this is 2 to the power of 1, this is 2 to the power of 2. So there's only 1 light up over here, so 2 to the power of 2 is actually 4. 4 in this case is actually 4 times 10 to the power of 0, which is just 4 itself. So actually you can see that it is only 4 base 10. Okay, so these are the conversions that you may need to really understand how it goes. Okay, nonetheless, if you want to convert maybe 1, 1, 1, 1. So how do we do? So we have a so this is actually 8 8 plus 4 plus 2 plus 1. Okay, so we have a 12, 15. So we have a 15 over here. So if you were to convert this thing into base 10, okay, it's actually 1 times 10 to the power of 1 plus 1 plus 10 to the power of 0, which in this case is just taking out the 1 and 1. So it's just 1, 1, 10. Okay, if you want to verify, we can go to the computer effort. It should be, yeah, this thing should be 5 times 10. 5 times 10 to the power of 0 is actually 5 times 1, right? Because it's 15. So this is 10 plus 5 equals to 15, so this is 15. Okay, my fault. Okay, so what if you are given 2, 3, 4? Then you are told to convert into base 2. So what are we gonna do? What can you do? So first you need to do is actually to do 2, 3, 4 divided by 2. You have 117. So since divided by 2, you know that there will be a 2 over here, so it's 1. And then since you know that is 116 goes to 116 plus 1. Okay, this is 117. There's only one odd numbers over here. 2 to the power of this is 1. You know that there will be a 1 over here. So you can straight away continue to divide by 2. If you divide by 2, you will get 68 if I'm not wrong. Okay, maybe I should hold on a while. I thought we have a shorter method. 2, 3, 4 divided by 2 equals to 117, right? So what is the next one smaller than 2 to the power 7? You know 2 to the power 7 is 128. So this is actually bigger than this one, so we can't use this. But we know that 2 to the power of 6 is actually 64. So we can put here as 1. So 117 minus 64. So you know that, okay, nonetheless this is 2, right? So you just put a 1 over here also. So if you minus 64, what do you get? So now you have 53. So 53 is 52 plus 1, right? So you can actually, you know there is a 1 over here. You can straight away have a 1. Then you can continue here to get 52. So you know that 52, what is the next one? 2 to the power 5 is actually 32. Okay, so 30 minus 32 is actually 20. Nonetheless, maybe I should write down. This is 64, 32, 16, 8, 4, 2, 1. Okay, so actually you can see this is much clearer. So I'm thinking because 52 is actually larger than 32, the next one, so actually I can straight away take in this one over here. So that 52 minus 32 is equals to 20, so 32 exists inside this number. So we have 20 now. So you know that 16 is inside 20 also, because now 20 ma. So 20 minus 16, you have 4. So you know that there is only 1 4 over here, and there is no 8. So you can know that this is your binary number of 0 1 1 1 0 1 1 1. Okay. So if you want to double check, you can go to the site. If I type 2 3 4, no. Okay. If I type 0 1 1 1, okay. If I type 0 1 1 1 0 1 1 1, if I were to ding ding, my fault. I shouldn't multiply. Damn, what the fuck am I doing? Okay, I think you can just ignore this one. Okay. So if you are given 2, 3, 4, okay, if you are given 2, 3, 4, the first thing you need to do is actually to write out 1, 2, 8, 64, 32, 16. You know that 1, 2, 8 is the largest bit of 8-bit. And if you write it down, if you sum it up, ensuring that, so you sum out the largest one. So if I sum out 1, 2, 8, I sum out 64, okay, what do I get? Okay, maybe I should calculate myself. 192 plus 32. Actually, I can plus another 32 in order to get a 224. Okay, which is 10 values smaller than 234. Okay, if you don't know what I mean, if you understand what I mean, if you don't believe what I mean, 128 plus 64 plus 32, 224, right? So this values comes from this bits, okay, 2 to the power 7, 2 to the power 6. And then 224, so now we have left with 10, right? So what are the values that is 10? So it's 8 and 2, right? 8 plus 2 equals to 10. So our values are 128 plus 64 plus 32 plus 8 plus 2. You will have 234, right? So in this case, you can know your binary numbers already. You have 1, 1, 1, 0, 1, 0, 1, 0. So if I were to sub it inside, I should have the value. 何これ 0, 1, 1, 0. Ding ding. Hey, 1, 0, 1, 0, sorry. 1, 0, 1, 0. Yeah, I have 2, 3, 4. Okay, so this is how I get my thing. Okay, so I hope that I think I confused a lot, but yeah. So these are the things for ADC, DAC, whatever thing that is. So yeah, to conclude, maybe I should conclude in the next video lah. So see you, bye bye.